Alrighty, want to do a little quick update on the 3D printing projects, the latest projects, more so to motivate to the Dobsonian mount ultimately for the satellite dish. Though in the meantime, kind of like with the 3D printer, studying the CNC controls methods and the range of different devices that are just super simple to make. I mean, there's like sonars and radars with Arduinos that they're really easy to make, and they're not all over the place on the internet, but they're there. If you look around, you can find them. And there's a few I figured I'd do a little update to see what's the latest and greatest. I haven't really, looked into or seen before. And there's this cool little do-it-yourself simple RSSI antenna tracker. And what this gentleman's doing is basically taking this little device here, which has two little receivers, and there he's tapping the RSSI signal. As you can see here, there's like a receiver on this side and a receiver on the other side, and those signals are tapped. And I assume, I really don't, I guess I don't really know. Um, the RSSI, I'm guessing it's digital. I probably know this. I'm not recalling, but I think it's a digital signal. And where I'm looking at, not really this type of design that I'm going to show you. That there's like these analogs in the solar world, um, though similar in regards to the analog signal intensity, but not the digital signal. I think the RSSI is a digital signal at least. So I just wanted to document this. I thought it was kind of cool. It was neat. So I'm documenting it. And then transitioning over to this little design where I'm kind of going to segue at the end uh, with the 3D print and then the latest methodology for the least amount of material used with 3D printing, and back to the really mindset of building something that's going to last too. But I'll get to that in a bit. I want to print out some of these gears, and there's some really cool herringbone, and there's these helical spiral gears that are really, I think the helical spiral gears are actually a little better in regards to efficiency. So, but there is a design that's easy to print. I'll show that in a second. I guess I can just move to that real quick. Not this one. This is just a really cool 3D print system I don't need, but I think it's really cool. Here it is. Here's the 3-axis. And the first design by Isaac879 is with the slider. It's just this upper part gimbal. And I wanted to print these gears mainly. And that's really first off. And I'll come back to this. I want to go back to where I was here. This little design I want to explain because it's very simple. And similar to the designs here, we have two signals. And thinking from the perspective of a direction, you're looking at a vector this way with a magnitude and a vector that way with a magnitude. And by comparing the two signals, you're able to guide using some sort of algorithm the motor, the control system, to focus in on whatever that signal is of interest. So in this case, you have solar energy radiating in to the solar panels, which is a photovoltaic cell, which is going to produce a potential. So that's also going to produce a current also. So you're going to have volts and amps, basically. You're going to have some power generated. Well, you wire up this one side, say, for example, as positive, and then you wire up the other side as negative. And then you wire those into the motor parallel. So basically you take each wire lead and you go to that same point where you connect the wires. So when you're centered on the energy source radiating, you'll get equal amounts of energy radiating on each panel. So you'll have a positive, say 2 volts, and a negative 2 volts. And when wired in parallel, that's going to amount to sum up to 0 volts. So the motor will stop. So if you're getting more on this side, say, you'll get positive you'll rotate the motor till this side gets equal, and then it'll stop her the other way around. So it's really cool, neat, super simple. This is like the simplest design that I've found. And there's actually more simple designs which are really cool. So I'm going to show that next. It's kind of a tangent from the RF detection and tracking. Though it's a neat review, and I kind of wanted to share this because I just think it'd be a cool vlog topic. And I think something useful for the solar panels I have when I do get them installed and with a limited, surface area to work with to maximize the efficiency of those solar panels. Well, this is an old-fashioned Amazing from 1977. It's really not that old. I was born a year after. In December of 77. I was born 6 months after. Though this here, you have a solar hydraulic design, and it looks like they're using as a working fluid Freon. And there's some other designs out there also, and I'm not sure if Freon's going to have the most force. I really don't know. I'd have to read into, but this is a really cool design. Similar concept, paradigm of thinking. You have one side is going to be the negative, basically, side of the cylinder. The other side's a positive side of the cylinder. When they equal out, the energy intensity radiating on those solar concentrating parts are equal. This is going to be the net effect is going to be zero or equal volumes on each side of the cylinder. There's a newer design, and this newer design is using a parabolic concentrating trough section, and it looks like that center point is a vacuum tube to better store the energy. And then inside that vacuum tube is going to be your heat expansion cylinder. And inside that, looks like they're using some sort of engineered paraffin wax as a hydraulic actuator. This is where I'm not exactly certain how this is working. I have to think about it. I just saw this today, so this is like completely new to me. The other designs I've seen before, but this is completely new. And this design, I'm not exactly sure if there's like a helix in there, a helix. So when that expands, there's a rotary action going on. I don't really see that. Unless there is a linear actuator. It doesn't really say linear actuator anywhere. So I'm not sure if there's a rotary act going on or what. Like, I have to look at the pictures more, and I don't see anything mechanically linear translating into perpendicular motion. It almost looks like it's attached there. So I don't know. It's something to look into more. I just think that's a cool design. I wanted to share that. And they're kind of not really exactly related, though kind of food for thought, for inspiration, for tracking, since, this design's literally just a one-axis tracker that can be modified to have two more antennas and another motor, stepper motor, to perform a two-axis tracking, which, like this gimbal, technically you could have set up on this type gimbal and be performing. Now granted, this is going to be a more expensive design. It's not just using the cheapest servo motors out there. However, you can if you wanted to. And this is going to be kind of where I talked at first, noting the 3D printing, what I printed out today. I've been wanting to print this out for a while. I just don't really see having like two point tilt. Actually, they're technically zoom also cameras. I already have the cameras. I don't really want to waste the filament to print more, though it still seems like a really cool, toy to have, just like a lot of the other projects. I don't use them as much as I'd like to, though what I want to focus on is more the radio direction finding and tracking too, like when locked into a signal. The design I'm thinking is going to be more of a sweep, like manual. You're kind of doing this back and forth, up and down, until you get maximum signal, and then you're just going to focus on it, and you're kind of like jitterbugging to track. and then you'll average out your trajectory and be able to, map that, whatever, I guess 2 or 3 dimensional if you want to. Technically, you could put a focus on there also and get some other depth, which would be really neat actually, would be having your telescope mounted. And I don't see using this same design, though very similarly can be with probably pulleys with a Dobsonian mount. So, and that's where I plan to focus on with the dish. But I wanted to know, so I started printing this, and my thought was I'd just print the gears. So I printed the gears. I wound up slicing in quadrants. So I did like, the XY, negative XY, negative X, negative Y, and negative Y and X. And this is you can see down here the gear. And then there is, it's over here, the other gear. And then I did the other gears. And then I printed this, I started printing the mount. And this is actually on this side where the motor mounts. And I decided, I'm like, why do I want to do that? I happen to see this article, like I've got aluminum material, even steel I can use. So I'm thinking I should probably use something like more stiff, solid, long term's gonna be better, especially for an antenna that's outside. Why use, even if it's like PVC plastic, or vinyl, why use something 3D printed when I can just as easy, other than the mess with cutting. I admit that is kind of messy, but more challenging projects, I'm thinking I'm better off the 3D print. So I saw this article, and it's basically an OpenSCAD, which is a bonus too, because I've downloaded and installed it on another computer. I just haven't started using yet for designing the 3D prints or other projects. But this woodworking aid, basically a jig. So that got me thinking, inspiration station for, I even made a comment too before I started the prints out. I'm like, why not, press fit or, design to put a nut and then drill out for a longer term jig. It's, so I'm like, okay, I'm not going to print anymore out. I'm not going to print this out. And I kind of went back and forth. I think it was like I saw the comments or something. I had commented again because I had, that's what it was. The YouTube video, there's a reply. So I commented, and I'm kind of like in the middle of this because I had started printing by then. And I'm like, I'm just going to slice these other parts thinner. And actually, I'm just going to take off sections where I can use the template. And like this part, technically it's this part, and then the bottom part, this base here, this part, and then back where the stepper motor mounts. And I made sure to leave this section of the larger tooth gear profile, so I know, like, when I'm cutting out the bigger section where the already pretty much predefined points are, so I can pretty much do what do they call those, a center punch, I think is what it is. A punch that has that outside diameter already, so it punches in the center like perfectly, or pretty close for manual. So I figured I'd note that, and hopefully this isn't a super long-winded. But it looks like only 13 minutes. So it was a little update, and I was kind of thinking I wanted to get moving forward with the controls at the very least for the Dobsonian mount, and kind of still keep thinking about how am I going to make that in the large 10-foot dish scale, and while at it, thinking, if I'm getting that large, why not add the telescopes? So add telescope, add maybe some other antenna or detectors that are directional onto that large Dobsonian mount while I'm at it. And with that, in regards to materials, I was planning to make with wood. Figured I'd use like V-Carve and then the Fab Lab. Already had coordinated, was going to do it something like it's like excellent, really decent pricing, at least like $20. And I started thinking some more. I'm like, man, I don't know, marine grade. It's still gonna cost more, but it's like, I probably could get some free materials. And I'm like, duh, I already have like a bunch of free materials. So though the profiles, how am I gonna make those, big arcs, those radius, and so that kind of got me to hold off again. And then like, do I need those? Maybe I just have like a large, you know, a large gimbal type design that's somewhat that same Dobsonian mount, literally, and I just use maybe that 2 inch by 2 inch square stock and just make this little cradle mount, the big side truss points to hold that up. And then this bottom part, where like with the wood, I was thinking I'd make like a PVC, kind of inspired from the PVC roller coaster track. It'd be easier to make a big circle. And then that kind of segued into, well, maybe I'll just do like a cement footing and I'll make a center point and then take like a 2x4 or something, the length, and then make a rounded or a track profile in the cement, just sweep around, keep going over that cement till I have that depression profile smoothed out really well, so it's like super smooth. And then just, put like a tire on that and then have a center point and then just rotate that way. And then I talked to it was email? Yeah, email correspondence. I think it was on YouTube. Yes, email correspondence. The gentleman who made like these roller coasters out of PVC with wood for his children, and we're back and forth. I mentioned maybe cement or rebar fill in the PVC, and he thought probably suitable, but if you really want something heavy, you want something heavy and stiff for what you're doing for tracking, something solid. He went back to and recommended I use steel, so that left me in the okay, I probably should use steel, and I can always put an axle on that, and so it kind of left me with, okay, I can put an axle on it, and post having um, the electronic hammers for pin footing, I can drive pin footing and then, pull those out later, basically rotate with a pipe wrench and beat back out those if I wanted to, or rotate out, to pull those footing out and still have a trailer that can, foot into the ground and have a solid base for that heavy duty of a system, even if you just use like trailer jacks to level everything off. I'm still thinking you'll want to stake everything in with pin footers. So I kind of left off there, and what else did I leave off on with that? That's about it. I think that's coming to mind. Might be something else I just am not thinking of offhand. So I get back to the controls and focus on those controls, and keep moving forward with the design. I think the software is going to be easy. It doesn't seem too complicated to me. I think mainly getting the actual hardware, made. That's going to be the more time-consuming challenge. Um, Amazingly, I'm not getting pulsed right now, which is pretty cool. I thought I would be, but maybe putting that video out yesterday and talking about help. So, okay, get back to whatever it was I was doing and leave that at that. Everybody have a good one and be safe, stay healthy, and until next time, peace.